Welcome back to live session in Crash Course NEET Physics. Now, the chapter 14, Semiconductor, Electronics, Materials, Devices and Simple Circuits, we are going to discuss. These are the electronic components. We know that is computer or electronics. Now, without these things, we can't imagine. What is this? This will be a resistor, IC chips, transistor, and this is IC. IC is an integrated circuit. And these are all optoelectronic devices circuit. IC chips, integrated circuits. Classification of metals, conductors and semiconductors. Basically, solids are classified into three based on the conductivity. On the basis of conductivity, relative to electrical conductivity or resistivity, solids are classified as metals, semiconductors and insulators. Metals, what are metals? Metals are the material which has low resistivity or high conductivity. Resistivity is of the order of 10 power minus 2 to 10 power minus 8 ohm into meter. Conductivity, what is conductivity? It is a reciprocal of resistivity, value 10 power 2 to 10 power 8 S m power minus 1. Actually, its unit is mho per meter or other unit Simon per meter. S represent Simon per meter. Semiconductor. Semiconductors have resistivity or conductivity in between metals and insulator. Actually, insulators have high resistivity or low conductivity whose resistivity is 10 power 11 to 10 power 19 and conductivity 10 power minus 11 to 10 power minus 19. And semiconductor. Semiconductor or the material whose conductivity or resistivity is in between metals and insulators. That is, resistivity is 10 power minus 5 to 10 power 6 ohm into meter. And conductivity 10 power 5 to 10 power minus 6 S per meter. Okay. Band theory of solids. Actually, just like natural theory, we studied, that is the natural theories of light. Corpuscular theory, wave theory, electromagnetic theory, dual theory, like that. Like that, here also different theories are there. That is, one is classical, first one is classical free electron theory. Classical free electron theory. Second one is quantum free electron theory. One theory explained one topics about, that is properties about the metals. Quantum free electron theory. And third one only band theory. Band theory of solids. And band theory only explains the electronics. Okay, band theory is after band theory only electronics plays a very vital role in the communication. A solid is a large collection of atoms. Energy level of an atom gets modified due to the presence of other surrounding atoms, and the energy level in the outermost shell of all the atoms form valence band and the conduction band separated by forbidden energy gap. That is, suppose energy levels are electrons, more energy levels are electrons or neighboring atoms, all are overlapped and then forms one region. That is called band, energy band. And a region containing valence electron is called valence band. Okay. Similarly, region containing conducting electrons are called conduction band. In between these two, there is a gap or region will be there, that is called forbidden energy gap or band gap. We studied in previous topics, band gap of the, where you studied, that is in laser and all, that is in LED you studied. Lambda equal to Hc by Eg, like that. Hc by Eg. That is, Eg is a band gap or forbidden energy gap. That is what, and highest energy level which an atom can occupy in the valence band at 0 Kelvin is called Fermi level or Fermi energy. And actually in EC students I said no, that is, this is a very important topic for them, that is to determine the Fermi level, where is the Fermi level situated. Based on that only they will find the conductivity of the semiconductor. That is an important topic. And highest energy level which an atom, electron of an atom can occupy in the valence band at 0 Kelvin is called Fermi level or Fermi energy. In metals, the valence electron and conduction band overlap. See, valence band and conduction band overlap, and therefore no forbidden energy gap. That's why metals have more free electrons, easy to conduct. And in insulator, see, there is a large gap between conduction band, valence band. What is the value? 6 to 7 eV. What is eV? Electron volt. And that's why by applying very high energy also, that is, it will not conduct. That's why we are calling insulators. And for semiconductor, that is, gap is very small, of the order of 0.7 to 1 eV. Can you say any one example for semiconductor? Semiconductor example. Example for semiconductor. Germanium, silicon. Germanium band gap will be 0.7 eV, silicon band gap 1.1 eV. Germanium 0.7 eV. Okay. Intrinsic semiconductor. Intrinsic semiconductor, basically that is, a semiconductor is classified into intrinsic semiconductor and extrinsic semiconductor. Intrinsic semiconductor is a pure form of semiconductor in which electrical conductivity is totally governed by electrons excited from valence band to the conduction band, and in which no impurity atoms are added. That is, a pure form of semiconductor is intrinsic semiconductor. Okay, and or added to increase the conductivity are called intrinsic semiconductor. That is, the impurity atoms we have to add to increase the conductivity. Then electrical conduction pure semiconductor occurs by means of electron-hole pair. Electron we know, hole. What is hole? Vacant site of electron is called hole. In an intrinsic semiconductor, Ne equal to NH equal to Ni. What is Ne? Ne is the free electron density. That is number of electrons per unit volume in conduction band. That is Ne. NH hole density, that is number of holes per unit volume in valence band. Ni is the intrinsic carrier concentration. See here, and this silicon or germanium is a tetravalent element. What does tetravalent means? Valency is 4. See, that is, this one element contains 4 electrons, 1, 2, 3, 4. And each electron bounded with the neighboring atom electron and forms covalent bond. Okay. And this is the complete bonding of electrons of the semiconductor or germanium or silicon. Both are tetrahedral valency. And basically, germanium or silicon is a insulator at 0 Kelvin, because see, each electron is bounded with the neighboring atom electron, and completely bounded means no free electron. So semiconductor is an insulator at 0 Kelvin, and when temperature increases due to thermal agitation, covalent bond breaks and electron and hole pair, this is only hole, electron and hole pairs are created, and these electron and hole pair only contribute for conduction. Electron will move in one direction and hole moves in opposite direction. Okay. Next, extrinsic semiconductor. What is intrinsic semiconductor? It is a pure form of semiconductor. That conductivity is not sufficient, so we need extrinsic semiconductor. Semiconductor doped with suitable impurities atoms, so atom, to increase its conductivity is called extrinsic semiconductor. The process of adding impurity is called doping. The process of adding impurity is called doping. And based on the type of doping added, extrinsic semiconductor is classified into one is N-type semiconductor, another one is P-type semiconductor. N-type semiconductor and P-type semiconductor. If the pentavalent impurity atoms are called donors because they donate electron to the host crystal, and the semiconductor doped with donor is called N-type semiconductor. In N-type semiconductor, electrons are the majority charge carrier and holes are the minority charge carrier. That is, number of electrons per unit volume is greater than number of holes. So, electrons are the majority charge carrier. And see here, this is a pentavalent element and it is doped with germanium atom or tetravalent element. Then what will happen? Pentavalent element means one free electron is extra, that is donate freely. That's why I am calling it is a donor atom. Okay, and therefore it is free to move. Next, P-type semiconductor. The trivalent impurity atoms are called acceptors because they create holes which can accept electrons from the nearby bonds. A semiconductor doped with acceptor type impurities is called P-type semiconductor. In P-type semiconductor, holes are the majority charge carrier and electrons are the minority charge carrier. In N-type, electrons are the majority charge carrier and in P-type, holes are the majority charge carrier. See here, this is a trivalent element. Then there will be a vacant site is there, that is hole. So, number of holes is always greater than number of electron in P-type semiconductor. Junction diode. If you join P-type and N-type, if you join P-type and N-type or sandwiched P-type and N-type, sandwich P-type and N-type, then we will get PN junction diode. It is formed by placing a P-type crystal in contact with N-type crystal and subjecting to high pressure so that it becomes a single piece. This is a PN type and this is the circuit symbol for PN junction diode. And diffusion of holes and electrons causes the depletion layer across the PN junction. Then the potential difference across the junction is called potential barrier. Potential barrier. And forward bias. When a P-type is connected to positive and N-type is connected to negative, then that is called forward bias. Okay, P-type is connected to positive, N-type is connected to negative. And during forward bias, its characteristic voltage, that is, voltage versus current will be curve obtained like this. And here, this voltage is called knee voltage. Knee voltage is the voltage in which current increases drastically. That is called knee voltage. What is forward bias? When a P-type is connected to positive and N-type is connected to negative. During this time, depletion layer will be very thin. And in reverse bias, P-type is connected to negative and N-type is connected to positive. And here the curve obtained is like this. Where is the curve obtained is? It will be in third quadrant actually. This is a graph, first quadrant, this is first quadrant graph, and here second quadrant, third, fourth in a graph, and it falls in the third quadrant of the graph. Forward biasing PN junction, this only I said, that is both electrons and holes move towards the junction and therefore depletion layer will be very thin. Then PN junction offers a low resistance. Current can flow easily in forward biasing. In reverse biasing, high resistance will be there. Potential barrier offers high resistance because thickness of potential barrier increases and it offers low resistance. If the reverse bias is made very high, the covalent bond near the junction breaks down and a large number of electron-hole pairs are liberated. The reverse current then increases abruptly to a relatively large value. This is known as avalanche breakdown. And maximum voltage that a junction diode can bear without break is called Zener voltage, and that type of diode is called Zener diode. This is a circuit symbol for Zener diode. Normal diode with Z shape, that is a Zener diode. Zener diode will be used as a stabilizer. As a voltage regulator means stabilizer. That is, AC input voltage of rectifier fluctuates, its rectified output also fluctuates. To get a constant DC voltage from the DC unregulated output of a rectifier, we use Zener diode. So to control the voltage drop or increase or decrease the voltage as a constant voltage, we need Zener diode. It is a stabilizer. Where we are using stabilizer in our electronic equipment? Yes, refrigerator. Not only refrigerator, that is in olden days, television, all the television should contain stabilizer. But nowadays, all the television is already equipped with stabilizer inside. That's why no need. Previous days, around 1995 and all, 1990 to 2000, I think, we need separate stabilizer for even television. Rectifier. What is rectifier? Rectifier is a device which converts AC, alternating voltage or alternating current, into direct current. The process of converting AC into DC is called rectification. And off-wave rectifier converts only one half of AC into DC, while full-wave rectifier rectifies both halves of AC. This is off-wave rectifier. That is, one half only rectified, other half opposite will be filtered. This is off-wave rectifier. Okay. In full-wave rectifier, see, that is this is the actual waveform, and that negative side also will be cut, and it takes only positive unidirection. This is a full-wave rectifier, and this is a circuit symbol for full-wave rectifier, and this is for off-wave rectifier. Comparison of off-wave with full-wave. Optoelectronic junction devices. Already we know optics means light, and semiconductor diode behaves under applied electric inputs. In this section, diodes in which carriers are generated by photon, that is photoexcitation, that leads to optoelectronic devices. That is, photodiodes used for detecting optical signal, that is called photodetector. And LED, light emitting diodes, which convert electrical energy into light. And photovoltaic devices which convert optical radiation into electricity, that is solar cell. Okay, solar cell. So this photodiodes, LED and photovoltaic devices all comes under optoelectronic devices. Opto means light with electronic equipments. Photodiode. A photodiode is again a special purpose of PN junction diode fabricated with a transparent window, and light falls on this and it converts light into electrical energy, that is photodiode. LED. LED here, electric energy is converted into light. Okay, this is a LED, and these are different colors of LED. LED we may know, its cost is very less, I think less than 10 rupees, I think, one LED. And even, and okay, this is the circuit symbol, and this is a energy level diagram for LED. And this is a IR LED, already I said no, in our remote at front point there is a LED, there is an infrared LED. Solar cell. Solar cell is basically converts light energy into electrical energy. It works on the same principle as photovoltaic cell, except that no external biasing. Photovoltaic cell, external biasing we need. Here no external biasing, and large area will be used for solar cell. Transistor. Transistor is a semiconductor device in which obtained by growing a thin layer of one type semiconductor between two thick layers of other similar type semiconductor. Three terminals are emitter, base, collector. This is for NPN transistor. This is PNP transistor. And this is a circuit symbol for NPN transistor. Arrow mark is acting outward. And for PNP transistor, arrow mark is inside, inward. Action of a transistor. When the emitter base junction of a NPN transistor is forward biased, electrons are pushed towards the base. As the base region is very thin and lightly doped, most of the electrons cross over to the reverse bias voltage, collector voltage, and since few electrons and holes always recombine in the base region, and here IE equal to IC plus IB. Here IB is the base current, IE is the emitter current, IC collector current. And there are three modes of configuration of transistor: common base mode, common emitter mode, common collector mode. CB mode, CE mode, CC mode. And CB mode, this formula and all you want to note down. Okay, because in formula we will use. That is, a current amplification in CB mode is alpha. Alpha equal to delta IC by delta IE. Delta IC is the change in collector current. Delta IE is the change in emitter current. VCB, collector base voltage. VCB maintained constant 2 volt. There will be a change in IC with IE, that is alpha. And common emitter current amplification factor beta. In CE mode, current gain will be beta. Beta equal to del IC by del IB. Okay, del IC is a change in collector current, delta IB change in base current. VCE, collector emitter voltage. And relation between alpha and beta, alpha equal to beta by 1 plus beta and beta equal to alpha by 1 plus alpha. You can note down these formulas. Can you move to next? Transistor as an amplifier. What is an amplifier? What is amplifier? Amplifier is a device which converts weak signal to strong signal. That is amplifier. And transistor can act as amplifier, and this is the circuit for amplifier. And in amplifier, some of the important terms we need, that is the AC current gain. It's denoted by symbol beta AC or AI equal to delta IC by delta IB at constant VCE. Delta IC by delta IB at constant VCE. And DC current gain, beta DC equal to IC by IB or delta IC by delta IB at constant VCE. Next, voltage gain of an amplifier. Voltage gain is the ratio between output voltage and input voltage, VO by VI. And AV equal to delta VCE by delta VBE. And if you simplify that, AV equal to beta into RO by RI. RO by RI is A or AA into AR. Therefore, voltage gain equal to current gain into resistance gain. Voltage gain equal to current gain into resistance gain. That is the formula. Power gain. Power gain is the output power by input power, that is current into voltage gain, or AP equal to AI into AV, or beta AC square into RO by RI. RO is the resistance, output resistance, and RI is the input resistance. Okay. Next topic, logic gate. This will be the last topic in this chapter. A logic gate is a digital circuit that has one or more inputs but only one output. Okay, one or more inputs but only one output. It follows a logical relationship between input and output voltage. Truth table. Truth table shows all possible input combination and the corresponding output for a logic gate. Boolean expression, it is a shorthand method of describing the function of logic gate in the form of an equation or expression or formula. It also relates all possible combination of inputs of logic gate to the corresponding outputs. Positive and negative logic. If in a system the higher voltage level represents 1 and the lower voltage level represents 0, then the system is positive logic. And if the higher voltage represents 0 and lower voltage represents 1, that is negative logic. And simply logic means 0 or 1. 0 or 1 only, that is a binary number. And this is a logic gate kit. I don't know whether you did in lab or not. Okay. So this kit you may use, I think. Is it so? This is a kit which contains all the gates. AND gate, OR, XOR, NOT, NAND, NOR, XNOR. And it's already, everything is sandwiched inside, and just we want to connect with positive source +1, -1 like that only. And we can verify it. There is a verify the truth table. And this is the with wiring. One such gate with wiring. How is it functioning? And this is OR gate. An OR gate can have any number of inputs but only one output. It gives higher output 1 if either input A or B both are high, otherwise the output is low. See, that is any one may be high or both are high, then output will be high as 1, 1, 1. And if both the inputs are low, then output will be low. Formula is OR gate for that A OR with B. A plus B equal to Y, it should be read as A OR with B equal to Y. And this is a circuit symbol for OR gate. And this is the truth table. Similarly, AND gate. Any number of inputs but only one output. It gives output 1 if inputs A and B are both high, otherwise it will be low. That is both A and B high, then only output is 1, otherwise it will be 0. And this is a circuit symbol for AND gate. A AND with B equal to Y. NOT gate. It is the simplest gate with one input and one output. And it gives us high output if the input is low, and it gives low output if the input is high. Then it should be read as A bar or A complement equal to Y. Should be read as not A equal Y. Symbol of NOT gate. This is a symbol for NOT gate, and if the input is 0, output is 1. The input is 1, output is 0. Reverse. And this is NAND gate. NAND gate is nothing but not with AND gate. A and with B whole complement equal to Y. And symbol of NAND gate is this one. This is a truth table. That is, its output is high when any one of the input is low or both the input is low, then output is high. Okay. And if both the input is high, output will be low. That is for NAND gate. And this is a famous question, repeated question, that is, why NAND and NOR is called universal gate? Why? Why NAND gate and NOR gate are called universal gates? Come on. Yes? No. Using NAND or NOR gate, it is possible to construct all the gates. Using NAND gate or NOR gate, it is possible to construct OR gate, AND gate, NOT gate, like that. Okay. So these two are called universal gates. NAND and NOR are called universal gate because it is possible to construct all the possible gates using these two gates, any one of the gates. NOR gate. NOR is nothing but not with OR. That is, A OR with B whole complement equal to Y. This is a circuit symbol for NOR gate. OR gate with one NOT bubble. And truth table, that is, it is high only when both the input is low. Otherwise, its output is low. Okay. And Boolean expression obey commutative law, associative law as well as distributive law. A OR with B equal to B OR with A, or A AND with B equal to B AND with A, or A OR with B or with C, or that is equal to A OR with B or with C. De Morgan's theorem, A OR with B whole complement equal to A complement and B complement. That is a product. And A product of B whole complement equal to A complement plus B complement. This is a De Morgan's theorem. And this is an integrated circuit. Concept of fabricating an entire circuit, that is consisting of many passive components like R, C. R is a resistor, C is a capacitor, and active devices like diode, transistor, etc. on a single block or single chip, that is called IC circuit. Shortly, integrated circuit. That is, one IC contains more than, that is a many number of transistor, many number of resistor, many number of capacitor. That is the IC, integrated circuits. And this is the integrated circuits which will be fixed in PCB. What is PCB? This is a PCB, printed circuit board. Does not require any wiring. See, any wiring is there. That wiring only given in the form of printed form. Okay, the printed form is a conducting paint, coated with conducting paint. So PCB means printed circuit board. Okay. Next to chapter 15, communication system. We'll complete this. Chapter 15 is the last chapter in the 12th standard, communication system. What is communication? Communication is a transfer of information from one place to another. Is it so? That is the communication. Transfer of information from one place to another. This should be done as efficiently as possible with as much fidelity, reliability as possible, as securely as possible. Communication system components, subsystem act together to accomplish information transfer exchange. That is, communication system that is contains components or subsystem that act together to form transfer or exchange. Elements of communication: information source, message or signal in the form of message, that is in the signal, and communication system, transmitter should be there, it transmits the signal. Channel, noise and all will be filtered there, or modulation will take place. Received signal, receiver received the signal, and user information. For example, we are talking through telephone. Then what will happen? And we are concentrating only in audio signal. Then audio waves convert into electrical signal using microphone. Microphone converts sound waves into electrical signal, and inside transmitter and all takes place. And later, after that, speaker converts electrical signal to audio signal, that is in speaker side. Other side you can hear the voice. Three parts of communication system. Communication system use electrical, electronic and optical modes for transformation of information from one place to another. It consists of three parts: transmitter, communication channel, receiver. Transmitter transmits from one end to other end. Communication channel, for example, in optical fiber communication system, optical fiber is the communication channel. Receiver, other end. Transmitter, receiver. Transmitter. Transmitter transmits the information or message signal after modifying it into a form suitable for transmission. Message signal for communication can be analog signals or digital signals. An analog signal is that in which current or voltage value varies continuously with time. A digital signal, discontinuous function of time. It's not a function of time, discontinuous function of time, that is a digital signal. Analog signal means sinusoidal wave, that is the analog signal. Analog, how is that means? Analog signal will be, I'll give white. This color is visible, no? Or we'll try for white. This is the analog signal, sinusoidal wave. And digital signal, this is the digital signal. As 0 or 1. This is 1, this is 0. 0 or 1. Okay, this is a digital signal. This is a difference between, and there is a AD converter, DE converter, analog to digital converter, or digital to analog converter, like that. Modulation. Message signal cannot travel over long distance. So we need carrier wave to superpose high frequency. That is called carrier wave. Power of modulated signal is boosted using a suitable amplifier, and amplified signal is radiated into space with the help of transmitting antenna. Modulation. The process of changing some characteristics such as amplitude, frequency or phase in accordance with the intensity of signal. That is called modulation. If there is a change in amplitude in accordance to intensity of wave, amplitude modulation. There is a change in frequency, frequency modulation. Change in phase, phase modulation. And communication channel carries the modulated wave from the transmitting antenna to the receiving antenna. That is the communication channel. And in receiver side, there will be antenna, pickup antenna. That is, even in olden days, we used even in our television antenna. There will be a 5-terminal antenna, 11-terminal antenna, 7-terminal antennas, like that. And even mobile also, olden days, Reliance and all has some antenna at the point. And a demodulator, reverse of modulator, and it should contain amplifier and transducer. Transducer means transducer is a device which converts message signal into electrical signal, or one form of signal to other form of signal. That is called transducer. And two basic modes of communication: point-to-point broadcast mode. Point-to-point mode, communication takes place over a link between a single transmitter and single receiver. Example, telephone. In mobile, we are talking to other person, no? That is a point-to-point, one single person to other single person. That is the point mode of communication. Broadcast mode. This in YouTube live session we are doing, no? This is a broadcast mode. Single transmitter and a lot of receiver. Who and all operate that YouTube? Who and all go to the future Dr. NEET Academy, that YouTube live session, they can receive. So that is broadcast mode. Single transmitter, large number of receiver. Television channel, television also is a single mode transmission one side, one particular drama or whatever, or sports, and other side, whoever can tune, they can receive. So that is a broadcast mode. Okay. Analog mode, already said. Analog mode means it varies time, usually in a smooth and continuous fashion. Digital one I drawn as a finite set of discrete elements as 0 or 1. And operational advantage of digital communication: improved security message, increased immunity to noise and external interference, a common format for encoding different kinds of message signal for the purpose of transmission, flexibility in configuration digital communication system. Basic terminology used in electronic communication system: transducer, signal, noise, transmitter, receiver, attenuation. Attenuation means decrease in intensity, that is called attenuation. Amplification, amplifier, range, what distance it should be, bandwidth, what range of frequency it will receive or transmit, that is bandwidth. Modulation, modulation we discussed, that is a process of carrying using carrier wave. Demodulation, detecting the signal, repeater, repeating the same process. Undesirable effects like attenuation, that is decrease in intensity, distortion, interference, noise, these are all undesirable things. This can be eliminated by filter circuits. Internet, it permits communication and sharing of all types of information between any two or more computer. Application includes email, electronic mail, www dot, what is that? Worldwide website, and file transfer, transferring file from one place to other place. E-commerce, electronic commerce, chatting. Even our WhatsApp is a chatting through internet. Mobile telephony, that is mobile telephony also we discuss, one transmitter and one receiver. Facsimile, fax, olden days we used facsimile, fax, that is just like Xerox thing. Here by typing that particular person, that number, it will be taken as a Xerox of that one. Electromagnetic waves. Electromagnetic waves are those waves in which there is a sinusoidal variation, that already we discussed. E and B are perpendicular to the velocity of propagation of wave, and that is equal to 3 into 10 power 8 meter per second. That we discussed already. Earth's atmosphere, that is troposphere, stratosphere, mesosphere, ionosphere. Troposphere up to 12 kilometer height. These are the various regions of Earth atmosphere. Stratosphere 12 to 50 kilometer. Ozone layer is present in stratosphere. Mesosphere 50 kilometer to 80 kilometer. Ionosphere 80 kilometer to 400 kilometer. Here atmosphere is in the form of ionized form of matter. Frequency range, medium frequency MF 300 to 3000 kilohertz. HF, high frequency range 3 to 30 megahertz. VHF 30 to 300. UHF 300 to 3000 megahertz. Super high frequency 3000 to 30,000 megahertz. Extra high frequency 30 to 300 gigahertz. Giga means how much? 10 power 9. And modes of propagation, ground wave propagation. Within one region to other region, one area, one room to other room, ground wave propagation. And within larger area of 2 kilometer or more than some kilometer distance, skywave propagation. Space wave propagation from one city to other city, one country to other city. Live propagation, live telecast is space wave propagation. Satellite communication is a space wave propagation. Microwave propagation, microwaves will be used, that is for short distance communication, microwaves will be used. Also used in radar to locate the flying object. Already we discussed what is radar, radio detection and ranging. Satellite communication, that is communication satellite, that is it is possible 3 satellite is sufficient to cover whole earth. That is this is earth, and 3 satellite which is at 120-degree angle, we can communicate whole earth. It is possible to communicate whole earth using 3 satellite is sufficient. Okay. Remote sensing, that is sun synchronous orbit, that is a communication satellite should be in geostationary orbit, and remote sensing satellite should be in sun synchronous orbit. That is for use to monitoring, weather forecasting, for that we are using. Optical fiber will be used for long distance communication. Nowadays that is even Geo fiber is there, and Airtel also trying to switch to fiber optic communication system, because there is no noise, no disturbance in optical fiber. And three types of optical fiber: single mode step index fiber, multi-mode step index fiber, multi-mode graded index fiber. LED or diode laser is a source to communicate from one place to other place. Light will be acts as a carrier wave to transmit the signal from one point to other point in the transmitter region. Line communication, that is a parallel wire communication, twisted pair wire communication, normal cable. Coaxial wire means this is a coaxial wire. Optical fiber is a coaxial communication. Twisted one, normal wire we are using now, positive and negative. That is a twisted wire communication. Parallel wire, two wire.